we shall now consider area between two curves about y-axis. To find area bounded by x equals gy from y equals c to y equals d, you just integrate c to d gy dy, you'll be finding this area bounded by x equals gy from y equals c to y equals d. Then to find area bounded between two curves, to find this region, so you take, let's say the two curves intersect at y equal to c and y equal to d. Then to find this area, you integrate from c to d g2y minus g1y dy. G2y is like the top curve. G1y, the red curve, is the bottom curve. So which means if you need to find area bounded by two curves, you can also find the intersection point, the y value. Then you do about dy. And of course you have to know which is the top curve, which is the bottom curve in it. So G2y is the top curve, G1y is the bottom curve. Let's look at an example. So for the same example we looked at just now in the previous video, find the area of the region in the first quadrant bounded by y equals square root x and y equals x minus 2. So you equate x minus 2 to square root x, like what I did just now in the previous video. You get x is 4 as an intersection point. And when x is 4, you can work out y. Y is just square root of x, which is square root of 4 is 2. Is 2. So with that, you get 2 here, the y value. And to find, you want to find the area A. So the red line is the top curve, the blue curve is the bottom curve. And to do about y-axis, you have to express x in terms of y. You have to express x in terms of y. It's g2y minus g1y. So which means you have to express x in terms of y. So from y equals square root x, the same as x is y squared. You just square both sides. If you square both sides, you give you x is y squared. Then for the second, the line y equals x minus 2, you make x a subject, so it's same as x is y plus 2. So red line is the top curve, which is y plus 2. So y plus 2 is the top curve. Then minus the bottom curve, which is the blue curve. X is y squared, so it means y squared, so it's the bottom. And then you consider the y value is from 0 to 2, 0 to 2. So integrate from 0 to 2, y plus 2 minus y squared. And you just do the integration, so it's y squared over 2 plus 2y minus y cubed over 3. Then you sub in 0 and 2. You get 10 over 3 as the answer. So you still get the same answer. And what you did previously. But previously, what you did was you consider about x-axis. So you do dx, right? And then you'll find that you have to find area under the curve from 0 to 4 of square root x minus area of triangle B using method 2. Then using method 1 is you find area bounded by square root x graph and the red line y equals x minus 2, and then the answer is too big, you subtract area of triangle, area of red triangle. So that means you have to consider a region, then minus area of triangle in method 1 and in method 2 as well. Then if you do about y-axis, right, then you'll find that you just do in one step will do. You just take x equal y plus 2 as the top curve, x equal y squared as the bottom curve, and then one integration without subtracting any area of triangle, you can find the answer. And this is the shortest answer to find the area in the first quadrant bounded by the curves y equals square root x and y equals x minus 2. You'll find sometimes you do about x-axis is easier, sometimes you do about y-axis is easier. So you can try out. If you find that finding by the area bounded between two curves about x-axis is difficult, then you can consider to use it, and you look at y-axis instead for the same question.